Hey everyone, this is section 8.1 for geometry. We're doing this live during period 2. As a reminder, those of you that are in period 2, if you wish to be on this video, you may go ahead and ask questions and answer questions. If you do not, if you don't feel comfortable, then please hold your questions until the end. Once the video is done, I will go ahead and answer anything that you have. Finding angle measures in polygons is what we're talking about today. Just as a reminder, the microphone does pick up quite a bit of what you say, and if it's muffled, it might be difficult to hear later on. Theorem 8.1 is the first thing that we're looking at. This is polygon interior angles theorem. And for those of you that were in class today, we talked a little bit about an introduction as to how we can actually form that theorem, which is n minus 2 times 180 for the measure of the amount of n's. So if you've got a pencil or something, you want to highlight or star that little piece, that would be pretty nice to have. Also, today we're talking about a corollary to theorem 8.1, interior angles of a quadrilateral. If you don't remember what theorem 8.1 is, like the exact 8.1, the big part is that if you have the interior measures of a polygon, regardless of the size, if you take the n number of sides, subtract 2 and multiply by 180, you'll get that measure. So example number 1 here, we're going to find the sum of an interior angles of a convex decagon. Okay, just as a reminder, a decagon has 10 sides. So using the formula n minus 2 times 180, we're going to say that we have 10 minus 2 times 180, or 8 times 180, which gives us 1,440 degrees. A lot of what we're going to be talking about within the next couple sections is going to be interior and then some exterior angles. One of the reasons that this is taught is because every once in a while in the SAT or ACT, if you're taking those types of standardized tests, even the PSAT, for those of you that are 9th grade, 10th grade, or haven't taken it yet, you'll see those soon too. Example number 2, the sum of the measures of an interior angles of a convex polygon is 2,340. Classify the polygon by the number of sides. So before, we had the n minus 2 is equal to 180 in order to find the degree. Here, it actually gives us the degree measure, so we need to find the sides. So I'm going to set up my equation, n minus 2 times 180, and set it equal to 2,340. Now, in order to find out what n is, okay, because that's what we want to do here, we want to solve for n, I'm going to divide by 180 first. You could distribute if you wanted to, but sometimes it's easier if you can divide that out. So you're left with n minus 2 is equal to whatever those numbers are. Now, I don't really have my calculator in here. Does anyone want to answer? Yeah. 13. Thank you. All right. And then we're going to add 2 to both sides. So we get n is equal to 15. So we'll have 15agon, or 15-sided polygon. Yes?
What does it mean when it says like a convex polygon?
So remember convex and concave are 2 different types. That's a really good question. Convex just means that the polygon doesn't really have anything that's kind of going inward on itself. Okay, here would be a convex, and then here would be something that would be like a concave, because it's caving in on itself. So good question. I'll put that in there for the notes too for the homework. All right. Looking at example 3 here, the last one on this page, the notes are pretty short for today. It says find the value of x in the diagram. So a couple different things that we know. Okay. we know that if we have n minus 2 times 180, we can determine the number of sides, or determine the degrees. So right now we're given the number of sides: 1, 2, 3, 4, 5. So 5 sides. So that would be our n. And what we're doing is we're trying to find x. So I'm going to plug in what I know. I know 5 minus 2 times 180 is equal to x plus 92 plus 110 plus 100 and plus 84. So now what I'm going to do from here, because I know all of those measures except for that x, I'm going to solve on my left, I'm going to solve down on my right, and then I'm going to try and get x by itself. So for example, if I'm solving on my left, I've got 3 now times 180 is equal to x plus, and now this is where I need to add all those numbers together. So I believe I get 386. Add those numbers together. So 3 times 180 is 540 equals x plus 386. I'm going to subtract 386 from each side. And x is equal to 154. Now, I know that I'm live in class right now, but just as a reminder, if you are watching this at home, you have the ability with a video to fast forward and to rewind and to pause and to play. So if for some reason you're going through these and you want to try them on your own first again, you can definitely do that. Pause the video. Or if you want to just go to a specific video, you can do that too by fast forwarding through. Right? Last page that we have for the notes today, only 3 more examples. These talk about the exterior angles of a polygon. I did say that was going to come up too. The sum of the measures of the exterior angles of a convex polygon. One angle at each vertex is always 360 degrees. Okay. So, exterior angles. Okay, and I'm going to write this in here. Exterior angles always equal 100 or 360 degrees. Sorry, 360. So no matter how many angles you have on something, if I draw a straight line out from it and I look at what that angle measure would be, they would always add up to 360. Which leads to example 4. Find the value of x in the diagram. Okay, if we take a look at all 4 of these measures, we know because they're all exterior angles. Okay, I'm looking at this angle, this angle, this angle, basically the ones that are labeled, are all going to equal 360 degrees. So I'm going to start, and I'm just going to go around. I'm going to add them together. X plus 20 plus 112 plus 96 equals 360. And now I'm going to combine my like terms. So x and x give me 2x. I believe, what is it? 20, 112, and 96 is 228. 228. Yeah. Yeah. Okay. Nice. Okay. 228. I wrote that wrong. So 228 is equal to 360. Okay. So now let's subtract 228. So 2x is equal to 132. Okay. Thank you. And divide by 2. And x is equal to 66. Okay. Leave that up there for a minute or for a couple seconds for you if you're trying to copy any of that down. Example number 5, just kind of moving along here so we don't have too much dead space. A convex hexagon, remember convex just means it doesn't go in on itself, has exterior angles with measures 34, 49, 58, 67, and 75. What's the measure of the exterior angle at the 6th vertex? I wouldn't mind hearing from you guys. What would I have to do? First off, what do I know and what would I have to do?
Well, we know 5 is the exterior angles.
Okay.
We're missing one.
Good. So let's put an X down for that missing angle. So 6 vertex, we'll name that X. And then what are all of those equal to?
Altogether, it's equal to 360.
360, good. Okay. So now let's add these up. So we've got 34 plus 49 plus 58 plus 67 plus 75, and then, of course, plus X. So now X is going to equal, somebody fact check me. I'm getting 283.
Yep.
Okay. It's not X it's going to be equal to. It's just going to be X plus 283 is equal to 360. So now let's subtract 283 from both sides, and we'll end up with X being equal to 77. All right. Hey, just as a reminder, a regular polygon is convex polygon that is both equal angular and equilateral. Okay. Regular means equal angular and equilateral. Here's an example for you off to the side just to kind of put in your notes. But say, for instance, we just have that, let's just say maybe it's a hexagon. Try and do this as best I can here. Okay. That means that all sides, these are the markings to say that all sides are the same. And then we would also have markings to say that all angles were the same measure. So if one angle is X, then all angles are X. If one side is X, then all sides are X. So a stop sign then is shaped like a regular octagon. Okay, so I know that most of you probably don't drive by now, but you'll be seeing a stop sign soon enough. It's shaped like a regular octagon. Find the measure of each interior angle and the measure of each exterior angle. So let's first start with A, the interior angles. Remember with this, we have 8 sides. So whenever we have n minus 2 times 180, we know that this is 8 minus 2 times 180, or 6 times 180. So we'll end up with a total number for the interior angles of 10, 8, 80. Okay? And I believe we found that out with our warm-up even at one point. So from here, it says find the measure of each interior. So if we're looking at the whole, it's 1,080 degrees, but each interior, we'd have to take 1,080 and divide it by 8. So each measure of the angles is 135 degrees. Part B, the measure of each exterior angle. Well, if we know that the measure of the exterior angles is 360 degrees, and we have 8 angles, then we take 360 and divide by 8 to end up with 45 degrees. All this is telling us, let me just draw this out for you so you can kind of see what I'm looking at, is if I continued to take each of these and I put an angle measure to them, okay, each of these measures would be 45 degrees. Okay, 360 divided by 8 would give us the 45s here. And then in the interior, each of these angles inside would be 135. And that is all that I have for you for today for this video.